Beneath Arctic ice, steel torpedo launch bays stand open to frozen water. The racks that once held Mark 13 torpedoes remain bolted to their tracks, empty but intact. This is a World War II torpedo carrier preserved in cold darkness for 8 decades. The wreck sits at a depth where light barely penetrates. Ice forms a ceiling overhead, thick and unbroken. The hull rests upright on the seafloor, its superstructure compressed but recognizable. Forward observation reveals the ship's primary feature: 2 parallel launch bays running along the port side, their hydraulic mechanisms still extended in deployment position. The vessel measures roughly 300 feet from bow to stern. Its beam is narrow, designed for speed rather than cargo volume. The hull plating is military grade, thicker than civilian transport ships from the same period. Rust has consumed the outer layers, but the structural frames remain solid. The superstructure rises above the main deck, though sections have collapsed inward. A bridge tower sits forward of the cargo area. Windows are shattered, but the frame holds its shape. Behind the bridge, ventilation stacks emerge from the deck, their openings now sealed by accumulated silt. The deck itself shows signs of rapid abandonment. Hatch covers lie open. Equipment remains unsecured. There are no orderly preparations visible, no careful stowing of gear before evacuation. The ship went down while still operational. Port side, the launch bays dominate the profile. Each bay is a recessed channel in the deck, approximately 20 feet long and 4 feet wide. The forward launch bays stretch 40 feet along the port side. Each bay held 2 torpedoes in tandem mount configuration. The hydraulic rails that guided weapons toward the sea remain locked in their final positions. These rails differ from standard destroyer mounts. They're wider, reinforced with additional crossbeams, designed for horizontal deck deployment rather than tube launch. The mounting brackets show modification marks. Welding patterns indicate the original frame was cut and reinforced, likely during a wartime refit. This wasn't how the ship left the shipyard. Someone altered these bays to handle heavier loads or faster deployment cycles. The portside positioning is deliberate. Torpedo carriers operating in northern convoy routes needed to deploy weapons while maintaining speed and course. Starboard mounts would have interfered with refueling lines and cargo transfer operations. The port configuration allowed the ship to launch torpedoes without breaking formation. Rust has consumed the outer plating, but the launch mechanisms themselves remain intact. The hydraulic cylinders show no signs of rupture. The control levers are still attached to their pivot points. This equipment was functional when the ship went down. Between the 2 bays, a loading platform extends from the deck. Its surface is scored with drag marks, evidence of repeated weapon handling. The platform connects directly to a hatch leading below deck. This is where torpedoes moved from storage to deployment. The cargo hatch drops into darkness. Descending through the opening reveals the lower hold, where stacked torpedo storage racks line both walls. Each rack is angled at 15 degrees, designed to cradle weapons without allowing them to roll during rough seas. The racks are empty now. Only wooden crate fragments remain, scattered across the deck plates. The crating was civilian lumber, not military issue. This suggests the ship loaded its cargo at a supply depot rather than a naval armory. Steel brackets protrude from the bulkheads at regular intervals. These secured the torpedoes during transport. The spacing between brackets matches Soviet Lend-Lease specifications from the middle years of the war. American-built torpedoes shipped to Murmansk followed these exact measurements. The hold carried at least 12 additional torpedoes beyond the launch bay capacity. This number comes from counting bracket positions, not guesswork. Each torpedo required 2 brackets for secure transport. 24 brackets line the walls. Ventilation ducts run along the ceiling. Torpedo storage required constant air circulation to prevent condensation. Moisture could corrode electrical components and compromise detonators. The ducts connect to a blower system near the engine room. That system is no longer operational. The deck shows flooding patterns. Water entered through the cargo hatch and filled the hold from bottom to top. Silt accumulated in the corners first, then spread across the floor. The flooding was gradual, not explosive. There's no evidence of hull breach in this section. Chain hoists hang motionless above the storage deck. Their cables extend toward davits, positioned for vertical torpedo transfer. The hoists are rated for loads exceeding 2,000 pounds. A standard Mark 13 torpedo weighed just under 2,000 pounds when fully armed. The winch assemblies bear manufacturer stamps. The text is partially obscured by corrosion, but enough remains to identify the source: a naval contractor based in Pittsburgh. These winches were produced between 1942 and 1944, when that contractor held the primary supply contract for Atlantic Fleet auxiliary vessels. The loading sequence is visible in the equipment layout. Torpedoes entered the hold through the cargo hatch, secured by the chain hoists. The winches lowered them onto the storage racks. When needed, the process reversed. The hoists lifted weapons from storage, guided them up through the hatch, and placed them onto the loading platform between the launch bays. This system allowed for rapid reload cycles. The trained crew could move a torpedo from storage to launch bay in under 5 minutes. Speed mattered on northern routes, where German submarines operated in packs. The davit arms show wear patterns consistent with heavy use. The metal is scored and dented where cables rubbed during operation. This ship wasn't a ceremonial vessel or a training platform. It worked. A control panel sits mounted to the bulkhead near the winch station. Its dials are frozen, needles pointing to 0. The panel monitored hydraulic pressure and cable tension. An operator stood here during loading operations, watching gauges to prevent equipment failure. The cables themselves are braided steel, resistant to salt corrosion. They've held up better than the hull plating. A few strands have frayed, but the cables remain largely intact. Sonar surveys in 2019 identified an anomalous metal signature beneath seasonal pack ice. The signal pattern suggested a large vessel, but its location didn't match any known shipping lanes or reported sinkings. Initial analysis assumed it was a fishing trawler that had drifted off course. Ice-penetrating radar provided the next piece of evidence. The radar revealed geometric structures inconsistent with commercial vessels. The hull profile showed military lines, narrow beam, reinforced keel, and a superstructure designed for speed rather than cargo capacity. A submersible dive in 2023 confirmed the identification. The dive team descended through a temporary opening in the ice, created by seasonal melt. The submersible's lights illuminated the torpedo racks first, then the launch bays. Military-grade steel plating covered the hull, thicker than anything used on civilian ships. No survivors ever filed reports about this sinking. No rescue operations were logged in the area. Naval archives contain convoy routes and casualty lists, but nothing matches this vessel's position or description. The ship simply vanished. Its location places it 140 miles north of documented convoy routes. That distance is too far to explain, as minor navigational drift. The ship traveled deliberately into deeper Arctic waters, either to evade pursuit or because its navigation systems failed during a storm. The wreck's position beneath permanent ice suggests it sank during winter. Summer ice melts enough to expose the surface. Winter ice forms a solid ceiling. The ship has remained frozen in place since torpedo carriers operated on northern supply runs between 1943 and 1945. These vessels transported American-built munitions to Soviet naval bases, primarily Murmansk. The route crossed some of the most dangerous waters of the war. German submarines patrolled the corridor, hunting for supply ships. This class of vessel wasn't designed for combat. It carried defensive guns, but its primary function was transport. Speed and maneuverability were its defenses. The ship's narrow beam and powerful engines allowed it to outrun submarine attacks if detected early. The open launch bays suggest the crew jettisoned torpedoes during the final hours. Dropping weapons reduced weight, which increased speed and improved stability. Ships in distress often jettisoned cargo to stay afloat longer. The timing of the sinking remains uncertain. Winter storms in the Arctic could disable a ship within hours. Ice accumulation on deck reduced stability. Waves that would be manageable in warmer waters became lethal when combined with freezing spray. German submarine activity in the region peaked in 1944. Allied convoy losses reached their highest levels that year. This ship may have encountered a submarine wolf pack and attempted evasion by heading north into ice fields where submarines couldn't follow. Alternatively, the ship may have suffered mechanical failure. Engine trouble in Arctic waters meant almost certain loss. Without power, a vessel drifted until it either reached land or sank. The ice would have prevented any rescue attempt. The cargo manifest for this vessel was never filed or has been lost. Wartime record-keeping prioritized combat operations over logistics documentation. Supply ships often operated under minimal paperwork, especially on lend-lease routes where secrecy mattered. Ice encasement halted the decay that destroyed most Arctic wrecks within decades. Biological organisms that consume steel and wood cannot survive in frozen water. The wreck remains in a state of suspension, neither deteriorating nor fossilizing. The intact loading mechanisms indicate the ship sank rapidly. There was no time to secure equipment or follow standard abandonment procedures. Winch cables hang loose. Hatch covers remain open. Tool racks still hold their contents. The empty launch bays combined with full lower hold storage tells a specific story. The crew deployed surface weapons first. They attempted to lighten the ship by removing the heaviest accessible cargo. The torpedoes in the hold were trapped below deck, impossible to jettison quickly. This sequence matches documented distress procedures. Wartime manuals instructed crews to drop deck cargo before attempting to access below-deck storage. The goal was to stabilize the vessel long enough to assess damage and organize evacuation. The lack of personal effects scattered through the wreck suggests the crew evacuated in an organized manner. There are no shoes, no clothing, no scattered mess kits. Either the crew had time to gather their belongings, or they left in survival conditions where personal items didn't matter. The hull shows no torpedo damage, no blast patterns, no entry holes consistent with explosive impact. If a submarine sank this ship, it used gunfire, or the vessel went down from other causes. Water temperature at this depth remains just above freezing year-round. The ice ceiling prevents temperature fluctuations. The wreck exists in stable conditions, unchanged since the moment it settled on the seafloor. The preservation allows for detailed documentation. Modern survey equipment can map the wreck without disturbing it. Each hatch, each bracket, each control panel can be recorded and analyzed. The ship serves as a three-dimensional archive of wartime naval logistics. The launch bays remain the most striking feature. They stand open, waiting for weapons that will never arrive. The hydraulic arms extend into empty water. The rails point toward a surface the ship will never see again. This is where the vessel's purpose is most visible, frozen in the moment between operation and abandonment.